The quantum nature of DNA. What is the weight measured in quanta? In biology, the evidence of quantum foundations in life processes is compelling. It's certain that quantum mechanics operates at all levels of life, not solely because chemistry, which frequently features in quantum mechanic discussions, is now a subject of study at the chemistry department of major universities worldwide. This study aims to deepen our understanding of the intricate interactions within these systems. Over the past few decades, neuroscience developed deeper into the subject matter, but it's often the case, as is often the case, the findings have only added to the complexity. A gray matter with a perpetual question at its core: how do the action potentials coursing through neurons and the chemicals traversing between them coalesce to create a being? John Eccles was a pioneer in early attempts to build quantum neuroscience. We won't mention the bias of the well-known Nobel Prize, but he was given it for his work on the synapse, a small space between neurons through which neurochemicals flow, exciting or suppressing neighboring neurons. He demonstrated that the cerebral cortex's incoming nerve impulses trigger the release of neurotransmitter molecules in parasympathetic neurons, hence exocytosis, via information transmission and quantum selection, which is directly related to consciousness. Since a conscious action, intentional that is a dynamic process that shapes temporal patterns in the relevant areas of cerebral cortex, it's been suggested how the regulation of multiple synaptic switches between millions of neurons in their respective regions could be effectively regulated by a quantum trigger, which later turned out to be based on the process of electron transfer in the synaptic membrane. After that, quantum biology began to evolve into full-fledged science with a wide range of coverage of everything that could reach, from quantum mechanisms which have been shown to play an important role in photosynthesis, vision, smell, mitochondria, DNA mutations, magnetoreceptor, and more. There's clear evidence that interactions of quantum nature are observed in brain proteins. We're talking about the most abundant protein in the brain, about 1 billion per neuron, tubulin, which is in the form of microtubules, each of which has unique high-frequency vibrational quantum properties due to nonpolar aromatic ring pathways. These cylindrical protein polymers are able to process information by performing purposeful spatio-temporal activities, determining the space of neurons and creating the regulating synapses. Tubulins were thought to be the base of memory, cognition, and consciousness. Experiments with the protein show that the conduction resistance of the microtubules becomes so low that it becomes almost an almost macroscopic quantum-like system. It would be reasonable to assume that in order for the quantum process to play a meaningful informational role in the brain, there needs to be a mechanism that can store and transport quantum information in qubits over sufficient long microscopic time. The mechanism must be able to entangle a huge number of qubits and then translate this entanglement to higher level chemistry to affect how neurons fire action potentials. The fundamental requirement was that the spins in the various CA9-6 molecules could become entangled and remain so for periods estimated to be many hours, well beyond the typical spin relaxation time of 31p. And as said, it turned out that not only chemicals and physical principles, but also quantum principles apply to DNA. It turned out that quantum phenomena are active in DNA even under environmental conditions and include coherent charge transfer along the overlapping pi orbitals of DNA bases and spin selectivity created by charitality. Those are filters electrons according to their rotation along the DNA. And that it's not only an indicator of quantum coherence, but can potentially affect the binding properties of DNA. The characteristic of a molecule that prevents it from being superimposed on its mirror image is known as chirality. This term originates from the Greek word for hand, heri, a familiar chiral object, as the left and right hands are mirror images of each other, yet cannot be superimposed in space. One of the stunning discoveries in biology was, for example, in 2007, discovery of the role of quantum mechanics in photosynthesis. Subsequent research shows that the light absorbed by chlorophyll must be transferred to cellular reactor for conversion, and it has been discovered that the cell's efficiency in transmitting light is nearly 100%, surpassing all existing technological capabilities and suggesting the existence of a quantum space that preserves the system's coherence, enabling the cell to achieve this level of efficiency. So in summary, it's important to acknowledge the profound shortcomings of physical theories in explaining various phenomena of consciousness, such as the sensation of self. Biological processes alone can't account for an organism's perception of itself as a unified entity. Activities like thinking, reasoning, decision-making, and sensory experiences, despite their complexity, are distinct from consciousness itself. And this is from Solask. Please leave your comments, and thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.